What's going on, everybody? Welcome to part 7 of our Python with NLTK for natural language processing tutorial video series. In this video, we're going to be talking about named entity recognition with Python's NLTK module. So let's go ahead and scroll on down here, and we really don't need any more of any of this. We'll comment this out for now. You might want to return to it later, but actually I'm going to get rid of it because I'm not using it anymore in this tutorial. So I'll get rid of it. Anyway, now what we're going to do is talk about some named entity recognition. So we've got tagged, that still has our parts of speech and all of that. And then what we can do is we can say named int for named entity, and that's going to equal NLTK.NE chunk, and then we want a chunk via named entity tagged. And then we can do named int dot draw. Now let's save and run that. Close this. Okay, so here you can see part of what is causing some problem immediately. We've got white house, so facility white, organization house, person Eric, but not catching Draper. But I think it doesn't catch Draper in this instance, possibly because there's no space between these words. Anyway, continuing along, no named entities found. Okay, served America, found that at least, thank you. And before we go any further, I probably should show you guys what these words even mean. So here are, I'll just paste them right in here. These are named entity type examples. So you can have an organization, a person, location, a date, time, money, percent, facility, GPE. This is just geographical kind of location-ish. So this would be a location, but this is more like a general location. So anyways, those are the types. Let's go back over to what we're showing up here. No named entities there. None there. Whoops, misclicked. Come on, give us another one. Drive me nuts. Okay. Our union is strong. Okay, so that was a correct grab there. So let's close this, though. Let's go over here. Close this. Okay. And what you can also do, though, if you don't care, it'll still pick these up. But if you don't care about these very specifically, what you can do is you can say this, and then binary equals true. And what this does for you is it just classifies everything as a named entity, period. It doesn't actually tell you like any organization, person, location, anything like that. Because like I said, sometimes it's just inaccurate. Unexpected indent. What have we done? It's probably just angry at this. I don't know. I don't see anything else that should give me an unexpected indent. Yeah. Okay. So here you can see that the named entity chunk was correct, at least in this instance, to chunk White House together. Okay. So that was good. It probably would have got Eric Draper if that space wasn't an issue. But anyway, it's finding these named entities now. I think we had a few to go before we found any more named entities, so I just want to kind of X out a few. Applause. I don't think we've made it past that. I can't remember. Shoot, it's clicked again. Yeah, I'm not really seeing any more identities. I can't believe we're not finding. Let's see if we can find a named entity. Protect our people. Maybe people should have been one. Oh, we found some though. Here's United States as a named entity, and so on. So anyways, good enough. We'll close this out. And let's go back one more time to the original version. Right. So if we look, we'll see here that these are separated when you did without binary. Okay, so remember this would be before it was binary equals true. This one, note to take out my trash. Someone do that for me. Facility, organization. So it's calling white and house separate, right? They're not actually being called the exact same, like they're not part of the same entity, as opposed to when we called this to be binary true. You'll find that they were not separate. See, they are part of the exact same. Gotta figure out how to get that little tag thingy to show up. I like that. Give me it. Whatever, jerk. There we go. Got it. Anyway, it's classifying them as the same named entity. So that might be useful for some of you if you are hoping to get those together. Same thing with Eric Draper. If that space wasn't there, it would pick it up. But I think if it wasn't binary, if it wasn't binary, it would probably say it's 2. Anyway, it can get kind of annoying. So NLTK's named entity recognition can be really useful, but it's like false positives are kind of high, and its error rate is also kind of high. So you'd want to have something else in place to maybe check the named entity recognition. But you know, that's it for the basics of the named entity recognition. It's actually pretty useful to have, but sometimes I go back and forth. Sometimes I'll use the named entity recognition, but sometimes I'll just look for nouns, and that almost works just as good. So anyway, that's that. You can also combine the two, though. Keep that in mind. So if you use named entity recognition, you can search for all nouns, and then also if you find a named entity that has 2 named entities back to back, chances are they actually should go together. Why NLTK doesn't have that kind of understood, I don't really know. I'm sure the people there are much smarter than me, so I'm sure there's a really good reason why. But anyway, that works for me at least. So maybe if you're looking for something specific like that, you might want to try that out. So that's it for the named entity recognition. If you have any questions or comments, please feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions. And until next time.